Hey there! Welcome to this in-depth guide to Django Subqueries. Subqueries are powerful features that allows you to embed one query inside another, enabling complex operations that would otherwise require multiple database hits or manual processing. Whether you are working on filtering annotations or aggregations, subqueries can make your queries more expressive and efficient. In this video, we'll break down the core concept of subqueries, explore their practical usage, and discuss when and why to use them. Let's start with the basics. A subquery in Django ORM is represented by the subquery class, imported from DjangoDB models. It takes a query set as its first argument and an optional output field as a second. A subquery is essentially a query nested within another query. Think of it as a way to pull in one precise result from a related table for each row in your main query. For example, suppose you want to fetch an author and their most recently published book published date field using annotate. Quite a challenge, right? But with Django ORM and subqueries, this is straightforward. No raw SQL needed. Now that we know what subqueries and why they are useful, let's jump into some practical usage with Django ORM and subquery in data annotation. To use a subquery, you often need two key tools: a subquery itself, which represents the nested query, and OuterRef that refers to the outer query's context, letting the subquery link to each row dynamically. Let's break it down with an example. Suppose you want to fetch the most recent published date for books by each author in the database. Here's how we can do it. We begin with book query here. This structure is designed to be used only with subqueries. If you run it by itself, it will just blow up. Let's break it down step by step, so that every piece of the query is crystal clear. Book objects filter after OuterRef ID. This part creates a query to fetch all books written by a specific author. The OuterRef ID dynamically references the ID of the current author being processed in the outer query. Think of OuterRef as a link between the outer query on author and the inner query on book. Order by standard ordering operation by publication date in descending order to ensure that correct object will be obtained. And values. It's here to determine what should be returned from a subquery, exact to one column. And last bit is slicing, which limits the results to a single entry, the most recent publication date of the book. Without slicing, the query would return all publication dates, all book rows for author, which isn't what we want. Next bit here is annotating this to a single author using subquery class and specifying an output field. Let's run it and see the result. As we can see from the output, this field was successfully annotated. This approach avoids writing raw SQL and keeps your logic within the ORM. Just for learning purposes, let's take a look how Django will interpret this query in SQL. We start by selecting all fields from the outer model, since we haven't used the only or values query methods to limit the fields. Next, we see the annotation block, where the subquery logic is applied. In this case, the subquery retrieves the data from the book model, limited to one result using slicing. After subquery's behavior in annotate, we will take a look how it behaves with filter. Subqueries are powerful when you need to filter data based on dynamic condition involving related models. Here is a scenario. We want to find authors who have written at least one book priced above 50. Instead of manually checking every book for every author, we will let the database handle this filtering using subqueries and the exist function, which is a main character in filtration with subqueries. Let's see the code. First, we'll create a subquery that checks for books priced above 50 for each author, and OuterRef link the subquery to the outer query, which in this case the outer model. Next, we'll use exist function from DjangoDB models to filter outers. Exist checks if the subquery returns any result for each outer, which is really help us to keep performance on a high level, because search is automatically stops when the first object is found. That's why we are not using slicing here. And as a result, after running this code, this will give us a list of authors who have written at least one book priced above 50. And worth to mention here that by doing this, all operations happening in the database, and there is no Python data processing. Let's move to the next section. Here we'll explore subqueries combined with aggregations. This is especially useful when you want to perform aggregation and include aggregate in your main query set. Aggregates may be used within a subquery, but they require a specific combination of filter, values, and annotate to get the subquery grouping correct. Consider this scenario. We want to find the total number of books for each author, but we don't want to manually count them in Python. Instead, we'll use a subquery to calculate the count of books for each author and annotate the author with that value. We'll start by creating a subquery, which counts the number of books for each author. In this subquery, we use OuterRef ID to reference the current author's ID. Next, we apply the group by technique by chaining the values and annotate methods in that order to group by the author, as briefly mentioned in previous video. We then annotate the result with count ID to calculate the total number of books for each author. And last one is values book count to retrieve only one field from a subquery. The order in which these query set methods are applied is crucial. In this case, since subquery must return a single column, calling values book count is necessary. This is the only way to perform an aggregation within a subquery, as using aggregate attempts to evaluate the query set, and if there is an OuterRef, this will not be possible to resolve. Next, we'll annotate on the outer query set with the result of this subquery. This will add a book count field for each author. Notice that we use slicing to ensure that the subquery returns only one value per author. But it's not necessary in this example, as our subquery using group by technique, and it's always will be one result per author. But it's always a good practice to have it. Finally, let's print the results. And we can see now quantity of books related to each author. Optimizing query set with subqueries. In this section, we'll explore how subqueries can be optimized in Django ORM to improve the performance of your queries, especially when dealing with large datasets. First of all, always slice the subquery. Even if Django handles limiting under the hood, explicitly slicing reduces memory consumption, which is always good. Next bit to optimize subqueries is by leveraging Django select-related and prefetch-related methods that we have learned in previous videos, which helps reduce the number of queries executed. In this example, instead of executing multiple queries for related authors, we can use select-related to efficiently fetch the related author data in one go. And here's a SQL difference between running it with select-related and without it, as we can see a difference here in this inner join, which was added by calling select-related method to prevent n+1 explosion. n+1 issue happens when Django executes a query for each related object, which can result in a large number of queries. And that's a wrap for today's video. Subqueries are a game changer in Django ORM, allowing you to solve complex query challenges while maintaining clean Pythonic code. Whether you are filtering, annotating, or aggregating, subqueries unlock new possibilities in your database interactions. Thank you for exploring subqueries with me. If you found this helpful, don't forget to like, subscribe, and share your thoughts in the comments. See you in the next one.